Hello Year 12 and welcome to the second part of this video here for exercise 605. In the first part we looked at activity tables and now we're going to look at critical paths, forward scanning and the earliest starting time. Now you can see here that I have a directed network graph, in fact a weighted directed network graph. I have a number of activities labelled A through H and they have numbers attached to them, that's fine. If, just as a bit of revision, I was to ask what is the predecessor of E, you would say D. D is also a predecessor for G. Predecessors of F are E and H. There are no dummy activities, I don't see any dotted lines. Okay, a start and a finish. The critical path is the pathway through this graph that is essentially the slowest. Okay, that any delay to the critical path will delay the entire project. We'll see that there are some activities perhaps within this project that can be delayed, right, without delaying the entire project, okay, because they're not as critical, right, that they have what we call a float time. So I've begun by drawing these boxes at each vertex, the start and the finish. They've got two parts, top and the bottom. We're just going to use the top half now. We'll use the bottom half of these boxes later on. We're going to put the earliest starting time for each of these activities, or at each of these vertices. We're going to put the earliest starting time in the top box. Now the way we do that is essentially we find the longest path to that vertex. So of course here at the beginning, right, the earliest I can start that is at day 0. Now to get to the end, to this point here, to this vertex here, it's going to take me, there's no two ways about it, it's going to take me 5, let's call them days. And to get up here, right, the 5 plus another 3 makes it 8. Now I'm not going to go here to the finish because, well, there's more than one way to get to the finish, so we'll just want to check that. Let's follow some other paths. Now to get to this vertex here between D and E, okay, it's going to take me 5 to finish A and then another 2 to finish D. So to get to this point here, when I'm ready to begin either E or G, it's going to take at least 7 days. At least 7 days. Who knows? Maybe it takes longer, but I can't do it in less than 7 days. Now that means here finishing G, ready to start H, at least 11 days. Now, to finish both E and H, remember I have to do both E and H before I can start F. They're both predecessors. Right, I will have to follow both of those paths. Now 7 plus 7 is 14. 11 plus 8 is 19. So in fact, it's going to take me 19 days at least before I'm ready to begin F. Okay, because that's the longest path to there, and I have to wait for the slowest thing to be finished. Now, from F to the finish is another 5 days. That's potentially 24 days. Alternatively, right, to finish activity C, I could have activity C finished in 8 plus 9 is 17. So, while I might have C finished in 17 days, I won't have F finished for 24. Okay, that's the slowest. So this is what we call the earliest starting time. That's the earliest I can get to that point on my graph. Okay, I might be able to finish B and begin C after 8 days. Right, I could say at this stage, right, if C represents my roof tiler, I could say, I won't be needing you for at least 8 days after I've started this project. Now we also want to find the latest starting time, and that's going to be something for our next exercise. But for the time being, earliest starting time, we work our way through, we draw these boxes with two parts. We're going to write in the top, and I find the longest path to that point, to that vertex. Rightio. That's it for this video. If you've got any questions, you know what to do. Ask me in class. Otherwise, I will see you there.